The reason you see my face up here is because I'm recording for our online students here. So let's talk about air pressure for a little bit. So question is what is air pressure? So right now, above us, we have the entire atmosphere above us. We're on the ground level. And above us is atmosphere. And actually, the weight of the atmosphere is actually pressing in on us right now. That's what air pressure is. Every square inch of our skin has 14.7 pounds of air on top of it. And that's also called PSI. So when you fill up your car tires with so much air pressure, like most car tires are around 30 or 40 PSI. Normal air pressure is 14.7 PSI, which means on every square inch of our skin, there's 14.7 pounds of air pressing on us. And so multiply 14.7 by however much air your body is exposed to, that's a lot of air. So my question to you guys is, why do you think that you don't feel that right now? Why don't we feel that weight of the air on top of us?
Because there's molecules pushing back against those air molecules on us.
Our body is pushing back on the air. That's one reason. Go ahead. Coming from all directions. The main reason you don't feel it is because you're used to it. You know, ever since you were a baby, you've had 14 PSI pressing on our body. If all of a sudden all the air has been sucked out of the room, you would notice, you'd feel different. You wouldn't be able to breathe either, but you feel the difference. You can wave your hand through the air. If you were in a vacuum chamber and wave your hand, you wouldn't feel that air rushing past you anymore. So that's what air pressure is. Air pressure is the weight of the atmosphere. So this is your next assignment for today. I'm just going to go ahead and work it. I'm going to work through it a little bit with you. So you got a picture of a mountain, and those little black dots represent the individual air molecules. I'm not sure if I did talk to this class. So remember, everything around us is made of molecules. Even the air around us are made of these tiny things called molecules. Do you notice how as you go up higher on the mountain, the molecules are sparser apart, or they're spread farther apart? On the right side, you also have this bag of chips. This little circle here is representing a bag of chips. And a bag of chips. Yeah. So as I raise this red dot, these pictures change a little bit. Oh, hope it doesn't do that every time. So as I raise the red dot, I'm changing my elevation. So as I change my elevation, if you look on this density, the molecules become less dense, or they become more spread out. So what that's saying is that at the surface of the Earth, that's where we have the greatest air pressure. And the higher you go up, the higher your altitude or your elevation, the more spread out or the less dense the air is. I also want to notice what happens to the bag of chips. Does the bag of chips get bigger or smaller as I go higher up? So let's do that again. I'm going to raise that red dot down. Now, as I raise the elevation, watch the bag of chips. Is the bag getting bigger or smaller? Bigger. What's happening is that food items, when they're sealed at the factory, they are sealed with that whatever atmospheric pressure was inside them. So like if I sealed a bag of chips right here in this classroom, and then I took it up in an airplane or went up to the top of the mountain, the bag of chips will expand because the air pressure on the bag of chips is higher than on the top of that mountain. So that air is trying to push on the outside of the bag and trying to escape. And so in this example, even though the air density is really low, I still have high air density inside the bag of chips. And so if I opened it, it would kind of like, you'd hear all the air kind of rush out. And actually the same thing is true for a soda. Whenever you open a soda, what do you hear? You hear that sound, right? That doesn't have much to do with, so that's air pressure again. That's not because it changed elevation. That's because your drink is carbonated. And that carbon, after shaken so much by transportation or whatever, that extra carbon dioxide wants to escape. So air pressure, no matter where you are on the planet, the higher you go, the less the air pressure is going to be. So, for example, if Missouri is pretty reasonably high as far as elevation, but if I went to the Ozarks, the air pressure is a little bit lower there. That's why if you drive really fast up a really tall road, your ears starts to feel that air pressure difference. Your ears start to pop. So the higher you go in the atmosphere, the lower the air pressure. That same is not true for temperature. Temperature is a little bit crazy. I told you guys yesterday, the higher you go in the troposphere. Did you guys remember the higher you go in the troposphere, does it get colder or does it get warmer? Colder. Maybe I didn't talk to this class about it. So for the troposphere, the lowest layer of the atmosphere, the higher you go, the colder it gets. But as you go up in the atmosphere, the temperature profile kind of zigzags, and we'll talk about that on Monday. But atmospheric pressure is pretty easy. The higher you go, the lower the air pressure. And that's just because gravity is trying to keep all that air down close to the ground. And so the air pressure at the very top, really close to space, it's going to have hardly any air at all because it's far away from the earth. You guys have questions about that? Sin, that means no. So after you finish your CK12 practice, you'll work on this simulation. You guys will play with the simulation, see how this changes things, and then you'll click this challenge me button, and you'll answer these 5 questions. And that's all you have to do to get you a grade for this one. You just have to play with the simulation and try those 5 questions. That's after your CK12 practice.